Hi everyone. Uh, I will discuss mass moment of inertia, and I will also calculate the mass moment of inertia of a following section like rectangular plate and circular plate and sphere. Okay? First of all, I will discuss the mass moment of inertia. What is the mass moment of inertia? Mass moment of inertia is resistance of rotation of a body about that axis. It is also calculate the mass moment of inertia of a dynamic equilibrium of the rigid body about that axis. So first of all, we will calculate the mass moment of inertia. I have considered a small solid body. The mass will be capital M, and now we will calculate the mass moment of inertia of this body about y axis. Let us consider a small strip of this solid body. The mass will be dm, and distance between this point to this axis will be x. Now mass moment of inertia of this small strip about y axis will be di y mass equal to dm into x square. Now we will calculate the entire mass of this section, this solid body will be Iyy m equal to summation of dm into x square. This equation will be equation number 1, and we can written as above equation is Iyy m equal to integrate of dm into x square. This point is known as mass moment of inertia of y axis. Now we will calculate the rectangular plate. We will calculate the mass moment of inertia of a rectangular plate about centroidal axis. I have considered a rectangular plate. Width will be small b and depth will be small d, and uniform thickness small t. This point will be centroid of this rectangular section. This line will be x axis and this line will be y axis. I have considered a small strip. The width will be small b and depth will be dy, and distance from this strip to centroidal axis will be y. Now we will calculate the area of this strip will be b into dy. The now area of strip will be b into dy. Now we will calculate the mass of this strip. Dm equal to density into volume of this strip, and density will be rho and volume this strip will be b into dy into t. Now we will calculate the mass moment of inertia of this strip about x axis. The x axis will be centroidal axis. Then we can return as the mass moment of inertia of this solid body will be di xx mass equal to dm into y square. We are already calculated the mass of strip and put the value of mass in above equation will be rho into b into dy into t into y square. This point will be mass of strip about x axis. Next point we will talking about whole strip, yeah, whole entire section about x axis. The limit will be minus d by 2 plus d by 2. Then we can written as Ixx mass integrate limit minus d by 2 plus d by 2 rho b dy into y square into t, rho b into t as a constant of this above equation. Then we can written as rho bt limit minus d by 2 plus d by 2 y square into dy. The above equation integrate bt into y qy 3 limit minus d by 2 plus d by 2. Then rho bt into bq by 12. We know that total mass of rectangular section will be capital M equal to B D T into rho. This point will be the total mass of that section, and we can written as that equation will be Ixx mass equal to capital M B square by 12, capital M B square by 12. Similarly, we will calculate the mass moment of inertia of the rectangular section about y axis. Iyy mass equal to md square by 12. Now, we will calculate the mass moment of inertia of a rectangular section about z axis. Z axis will be perpendicular to this point. Then we can use the perpendicular axis theorem. Izz mass equal to Ixx mass plus Iyy mass. Then M will be common, B square plus D square. This point will be mass of ZZ axis. Now next point, we will discuss the mass moment of inertia of a circular plate, a disc about centroidal axis. Now we will calculate the mass moment of inertia of a solid circular plate, a disc. We will calculate the mass moment of inertia of this plate about x axis, y axis and z axis. I have considered a small ring of this section. The radius will be small r and depth will be dr. Now the mass of elemental strip equal to 2 pi r dr into t into rho. Now we will take mass moment of inertia of that elemental strip about z axis. It will be Dizz mass equal to dm into r square. But we know that the dm of small strip is 2 pi r into dr into t into rho. Put the value of dm in equation and we get Dizz mass equal to 2 pi r dr t rho into r square. Now we will calculate the entire disc, yeah, solid sphere about z axis. The limit will be 0 to capital R. Izz mass equal to limit will be 0 to capital R and 2 pi R into dr into rho into t into r square. But 2 pi r rho into t have constant, and we get 2 pi r rho t limit 0 to r q into dr. Now 2 pi rho t into r की power 4 upon 4 0 to r. Now we can written as 2 pi rho t into r की power 4 upon 4. This one is the mass moment of inertia about z axis. But we know that the total mass of circular plate will be capital M equal to pi r square t into rho. We can written as the above equation will be pi r square t rho into 2 upon 4 into r square. Now capital M, this one is the mass of plate, capital M into r square by 2. This portion will be mass moment of inertia of a solid sphere about z axis. Now we will calculate the we will also calculate the mass moment of inertia about x axis and y axis, and we can use perpendicular axis theorem. We know that Izz mass equal to Ixx mass plus Iyy mass. We know that that plate will be symmetrical about x axis and y axis. The value will be same. Ixx mass equal to Iyy mass. Then we can get the value of Ixx mass equal to Iyy mass mr square by 4. Thank you.